Hello everyone, welcome to my channel Mathenthusiasm. Today we're going to solve this interesting Diophantine equation where x and y are positive integers. First of all, let's simplify the square root of 2023. It is equal to the square root of 7 times 17 squared. So we can take 17 out of the square root sign. Let's take a closer look at the equation. If we can add up the two thirds to get a single square root 7, then the simplest forms of square root x and square root y should also have square root 7. In other words, x and y should be in the form of 7 times some square numbers. Let's check out if it is really the case. To handle equation with thirds, we'll have to square both sides. Before that, let's change the equation a little bit. We put 3 square root y to the right and call this equation 1. You will see the reason in a minute. Now, we can square both sides of the equation. The left-hand side is easy, it is 4x. For the right-hand side, it is a perfect square, a minus b whole square, which is a squared minus 2ab plus b squared. We put a equals to 17 times square root 7, and b equals to 3 times square root y. So the right-hand side is equal to 17 squared times 7 minus 2 times 17 times 3 times the square root of 7y plus 9y. It looks quite complicated, but the good thing is it is changed from 3 square root signs to 1 square root only. Let's put it to the left. So it is equal to 102 times the square root of 7y. Then for 17 squared times 7, it is just 2023. We also have the remaining terms 9y minus 4x. Okay, we can square it again. Then all the terms are integers. Up to here, what can we say about y? Because we have these two square numbers, so 7y should also be a square number. Moreover, because 7 is a prime number, so we can let y is equal to 7n squared, where n is a positive integer. This ensures that 7y is also a square number. This form is nice because we can express x in terms of n as well. Let's put this back to equation 1. So the last term is 3n times square root 7. Well, the two terms on the right-hand side are like thirds. Both have square root 7. We can take out this as a common factor. So it is equal to bracket 17 minus 3n times square root 7. At this point, we get a range of values of n. Why? Because square root of x is larger than 0, so 17 minus 3n should also be positive. That is, 3n is between 0 and 17. In other words, n is larger than 0, but smaller than 5 and 2 over 3. Because n is a positive integer, so n is equal to 1, 2, 3, 4, or 5. Actually, we can further restrict the values of n. Let's continue to find the equation of x first. We divide 2 to the other side. Then square both sides of the equation. So x is equal to 7 times bracket 17 minus 3n over 2 whole square. See, that's what we expect at the beginning of the video. Both x and y are in the form of 7 times a square number. Now, 7 is an odd number. It cannot cancel with 2. So for x being a positive integer, 17 minus 3n should be divisible by 2. We don't have many choices. Putting the 5 values of n inside, n can only be 1, 3, or 5. Great, everything is ready. We just have to put these values of n into the two equations to find the values of x and y. When n is equal to 1, x is equal to 343 and y is equal to 7. When n is equal to 3, x is equal to 112 and y is equal to 63. When n is equal to 5, x is equal to 7 and y is equal to 175. These are the three sets of answers for the Diophantine equation. Pretty nice, isn't it? If you want to know more interesting questions of number theory, please check out the links of the videos and the playlist on the screen and the descriptions below. See you in next video.